So, without further ado, I do want to introduce Frank LaFurla. Frank has been Dean of the School of Biological Sciences for all of 10 months, but has already had a very significant impact. He's a noted expert on Alzheimer's disease, and prior to being Dean of the school, he's been on the faculty at UCI since 1995, and was most recently served as chair of the Department of Neurobiology and Behavior. Frank has also served as director of UCI Mind, which focuses on diseases such as Alzheimer's and Huntington's. Frank hails originally from Philly. Too bad about the Phillies this year, Frank. And he has a doctorate. He has a bachelor's degree from St. Joe's University and a doctorate from the University of Minnesota. And so without further ado, it's my pleasure to introduce Frank LaFurla.
So I want to first start off by thanking our friends at the Allergan Foundation for helping to sponsor this great event. And it's every year it seems like it's getting better and better and bigger. And so we're really honored to have this great partnership with Allergan and particularly with Dan. So I think we should give them a round of applause for their support. And also, I just want to call your attention to the fact that the school has a new name. We're one of the only named schools of biological sciences. And we are now the Francisco J. Ayala School of Biological Sciences. And I am also very lucky to be the Hannah and Francisco J. Ayala Dean. And we're even luckier that they're both right here in the first row. So we should thank them both. So now it's my great pleasure to introduce my colleague, Dr. Claudia Kawas. And I have to tread very carefully here because if I say something out of line, she will literally kill me. So I have to be very, very careful. I have some great pictures, but Claudia and I go way back. As a matter of fact, not many people know this, but she and I published a paper together before we both got to UC Irvine, I think before we even both met, back in 1996, when I was a postdoc and she was still at Johns Hopkins. Many of you are here to hear a really, truly great neurologist who you may have recognized her recently from her 60 Minutes experience. So not only is she a great neurologist, but she's also an outstanding TV star. And I have to say, if you know Claudia, you will know that she does not like getting her picture taken. So much so that one time I sold her a baseball cap with UCI Mind's name on it so that she wouldn't have to have her photo taken. So she paid me $20 not to have her picture taken. Claudia has done some truly pioneering work in the field of Alzheimer's disease. And she actually started her training with perhaps one of the most significant researchers in the field besides Dr. Alzheimer's himself. I think that's probably a fair statement. She worked with Dr. Robert Katzmann at that time and Albert Einstein, who probably after Dr. Alzheimer's was probably the most significant player in the field. And she's been at UC Irvine for almost 15 years now and is the principal investigator on a truly remarkable study called the 90+ study. And she will talk to us tonight about what she has learned from studying these incredibly remarkable individuals. And I think it's a topic that we're all concerned about, and there are some important lessons that will be shed tonight. So let's welcome my colleague, Dr. Claudia Kawas.
Despite what he thinks, I'm not going to kill Frank. If I had had intentions, I would have done it a long time ago. No, I want to thank Dr. LaFurla for his nice introduction. I want to thank every one of you who is here on a Thursday night when I'm sure there are lots of other exciting things you could do. And thank Allergan for helping to co-host this with the Ayala School and give me this wonderful opportunity. I truly am honored to be here. And so let's see what we can do and have fun tonight. So, how many of you have heard me speak before? She asks fearfully. Oh my God. Oh, this is going to be a real night. So all of you probably know who this lady is. Anyone want to tell the room for those who might not know? This is Madame Jeanne Calment. She was born in Arles, France. She met Van Gogh when she was a child and sold him paintbrushes. And she had a life that is full of many, many, many stories. But because we're talking about 90-year-olds today, I usually like telling the story about her when she was 90. So Madame Calment had a very nice apartment in Paris. And as was commonly done, people wanted her apartment, and so she made a deal with a man who was 47 years old, and he was going to pay her a monthly fee, and she keeps living in the apartment, and then when she dies, he gets the apartment. And this apartment would take 10 years of monthly payments at the rate that they agreed for him to pay the market value. So how much of the market value, for those of you who haven't seen her can imagine she paid? She got paid for 10 years. She got paid for 20 years. She got paid for 30 years. So now, not even counting inflation, he's paid more than 3 times the market value. And I guess it was too much for the poor guy and he died. I mean, he's 47 and she's 90, the odds are clear. And his widow paid for a few more years, because they really wanted that apartment. Right? So as many of you know, Madame Calment holds the Guinness Book World Record for the longest documented living human. She lived to be 122 and about 3 months old. She rode her bicycle until she was 100. She was ambulatory until she was about 115 or 16, at which time she broke a hip, and after that wasn't very mobile. She reportedly died without dementia, and in fact her mini-mental examination, which is a cognitive test that we give, was published when she was about 117 or 18, showing that she still knew who she was and where she was and all the most important things she needed to know. So for many of us, she gives us hope that dementia is not an inevitable consequence of aging, and that we can live to be 120 or greater. Or at least women can. The men have to work a little harder on catching up. Because as many of you know, the oldest man has never gone past probably 116 or 17. And in every species on the face of the earth, if there's a difference by sex in who lives longer, it's always the females. Men have never figured out how to outlive us. So that must explain why so many people studied aging only in males, and why so many animal researchers primarily only study aging and everything else in male rats. And as some of you may know, the NIH is working hard to make us realize that maybe men and women are different after all. So Jeanne-Louis really sets the stage, but I think that she's just the beginning of a tidal wave. And to give you an idea of the size of that tidal wave, I thought this was an amazing quote that I saw a few years ago, which is that essentially says that more than half of all the children born today in the United States and virtually all of the developed world can expect to celebrate their 100th birthdays. In the United States, it's actually, the estimate is that more than half of them will celebrate their 103rd birthdays. So we are living longer than we've ever lived before in the history of the world, and it's making a pretty profound change, not only for healthcare and medicine, but social and economic and everything else that's ahead of us. So that's a good introduction to why I wanted to study people over the age of 90. I've been in aging research and dementia research for more than 30 years, and I fell into it accidentally, and I haven't figured out any other place better to go. So it has been an incredibly rewarding thing. But my first attempt at looking at the old, what I call the oldest old, which in my definition turns out to be people over the age of 90, didn't happen until I came here and we started this study. And it's been apparent for a long time that the oldest old are the fastest growing segment of the population pretty much throughout the world. I think it's incredibly striking how we've ignored these individuals up until now. So individuals who are over the age of 90 have been systematically excluded from almost all major aging research over the last few decades. It probably started back in 1984, I think, when this criteria was published, the NIN-CDS-AD-RDA criteria for Alzheimer's disease. And most people can't even say those letters because none of those organizations still exist, but it's the criteria that we use both in research studies and in the clinic for deciding if somebody has Alzheimer's dementia. And the first line of that criteria was that you had to be between the ages of 40 and 90. So you could be 42 or 3 or 5 or 8, and I could give you a diagnosis of Alzheimer's disease. But if you were 90 or 91 or 92, I couldn't by this criteria. And at the time, I asked my mentor, who was one of the authors of this criteria, what is so special about 90? And his answer to me was, we just don't know. And I think that's right. These are pioneers. We know very little about them, especially 30 years ago. But the fact of the matter, because we've systematically excluded them, we know more about them now than we did then, but they are going to be taking over. All the research that's done with neuroimaging in Alzheimer's disease, almost all the clinical trials, and many other studies have systematically excluded or let subjects go when they reach the age of 90 because of this. So we've got pioneers that we don't know anything about. And I think the most important reason to talk about people being 90 is aging. When I first started in the field, everybody in my situation would say we worked in aging and we worked in dementia, aging and dementia. And you don't hear people say that anymore. Now they mostly say they worked in Alzheimer's disease. And Alzheimer's disease is an important thing, and I'm going to show you some things about it. But I think that we've sort of ignored one of the most important things, which is why is aging so relevant for so many things, not only in healthcare, but age matters. And so I think aging is the elephant in the room. And in the case of 90-year-olds, it gives you a very good group of individuals to try to study that elephant. So, in the past century, we've added 27 years to average life expectancy. There was an article recently in the New York Times and major papers saying that in the last year alone, we've added another month or two. And it doesn't look like it's stopping. I really thought that after we added these 27 years, we were kind of done. But it's apparent that the longevity continues to increase. And age is far and away the biggest risk factor for dementia. No matter what you know or what you think you've heard about ApoE or any gene or any head trauma or anything that anybody else is studying, nothing increases your risk for having dementia of all kinds, including Alzheimer's disease, as much as age. So, what I'm going to do for the rest of this time is give you a little background about the oldest old and the 90-plus study and how we started it. I'm going to talk about some of the research we did in this cohort, looking at what are the things that promote longevity. I'm going to do the same thing for dementia, and in particular talk about how common is dementia in this age group and what are the risk factors related to it. And then my favorite part, and actually about half of the talk, is really going to be particularly on what we find when we look at brains of people in this age group when we're studying dementia and what they can teach us about dementia, I think, at all ages. I'm sure many of you realize that dementia can happen at all ages, but I don't think maybe you completely realize the spectrum of it. I have many patients in my clinic who develop the disease in their 30s and 40s. It is really unfortunate and certainly a lot less common than in their 90s, but dementia affects all of us. And we really need to learn how to lower the risk at every age. So, here's what we've got right now in the United States. We have only about 2 million people who are over the age of 90. Some days I feel like we're studying all of them. The truth is we've only enrolled 1,700 almost now, but these 2 million people are pioneers that are really going to explode over the next few decades. So by the middle of the century in 2050, we expect more than 10 million people in this age group, and we expect them to be 2% of the US population. 1 out of every 50 people in the United States will be over the age of 90. It's going to be 6% of the population in Japan. So it's a staggering problem. And these individuals are our leading consumers of healthcare, and they cost us a lot. And right now, dementia in the United States costs far more than cancer and heart disease put together. So it is a looming problem no matter what you're coming from or what you're trying to go to. So in this slide, you see a bunch of studies compiled together from all over the world, actually. And what they show is at any particular age in that country, what was the chance of getting dementia in the next year. And you can see that around age 70, 75, and 80, we're talking about really pretty low levels of less than 1% or maybe about 3% per year of 80-year-olds develop dementia. You can also see that virtually all of these countries, whether they're Sweden and Netherlands or Brazil or Utah or New York, they're giving you pretty similar estimates right around in here. But then you notice that around age 90, where this line is drawn, that really things sort of start to go all over the map. I mean, although every individual study essentially doubles the risk of having dementia by every 5 years of age, exponential changes make them look quite different after a while. So some studies suggest that at age 95, that the risk of developing dementia is only 3 or 4% per year. Some studies suggest at age 95 that the risk of developing dementia is closer to 30% per year, a big tenfold difference, and then everything in between. Not only that, you notice that some studies continues to show this increase with a doubling of about every 5 years of age. Some studies suggest that maybe there's a leveling off, like this one here. And then there are other studies that suggest that actually, no, if you make it to age 90, and you don't have dementia, maybe your risk goes down. That maybe like many other age-associated diseases, if you don't get it at the age that most people get it, you might almost never get it. So we don't really know. There's a big tenfold difference. We don't know of those 10 million people that we're about to have. We don't know if this is going to be their risk of dementia or if this is going to be the risk. And we don't know if their risk is going to continue to double or if it's going to level off or go down. And not only that, we don't know when they get dementia, do they get the same kind of dementia that we're all looking at in 60 and 70-year-olds? And this was a really nice work done by one of my colleagues more than a decade ago, who pointed out that if you die with dementia and you're in your 70s and your brain goes to the pathologist, he's going to say, 5% of the time, I don't know why this person couldn't think, because to me their brain looks normal. And then if you look at the same brains when patients with dementia in their 80s, it increases to about 1 in 5 brains. But what's really staggering is that half of all cases dying of dementia in their 90s, he said the pathologist did not know what was the cause of their dementia. So we don't know how often people get dementia, but we also don't even have a clue what kind of dementias you get at this age. And if tomorrow we were to find the cure for Alzheimer's disease, we don't know if this would help these people a little, a lot, or not at all. So we wanted to look at all these things that are unknown in 90-year-olds. We wanted to see what made them live longer. We wanted to see what causes their dementia, how high is their risk. Are the risk factors that we know for dementia relevant to them? Are other risk factors important to consider? And so we started the 90+ study. So the roots of the 90-plus study were in an original study started by the University of Southern California. Do I have any USC grads here? You take some credit, good. So in their wisdom, they were interested, and they called it the Leisure World Cohort Study. And what they did in 1981 was they sent out a 14-page questionnaire to everybody who was living in the city of, in the retirement community of Leisure World, which is now, most of you may know, called Laguna Woods, California. They seceded from the Leisure World brand for a variety of reasons, most of which aren't I'm not going to go into, but they didn't like the term leisure. I think they didn't like taxation without representation and a few other things. And there are movers and shakers, and this is one of the largest retirement communities in the world. So in 2000, when they incorporated as a city, they actually are in the 2000 census and the 2010 census as the oldest cities in the United States. Not in terms of how long ago they were founded, obviously, but their mean age, which tends to be around 79. They've had 90-year-old mayors on more than one occasion. And it has been an incredible place to visit. For many of you may know, they have like 500 clubs, and they have their own television station, and they have their own newspaper, and I mean, they make me feel very tired and old. So 14,000 people, about 17 or 18,000 people were living in Laguna Woods at the time, in Leisure World at the time. And they sent a questionnaire to everyone, and they got 14,000 back. Just only in Laguna Woods, believe me. And these 14,000 people were consistent with the area, especially at the time, but still to a large extent, primarily white. Their mean age was 73, and so 2 out of every 3 people, consistent with the age of people at that time, were women. It's a fairly well-educated cohort of individuals with fairly moderate to high socioeconomic status, at least at that time. And this was just a questionnaire, though. This was a questionnaire where they said, how much they exercised, whether or not they took vitamin E supplements, whether or not they ate certain fruits and vegetables, what kind of activities they did. So it was all done through the mail, but they mailed these answers back, and then they had follow-up mail surveys done 4 times more over the next 20 years. And an incredible amount of important things have come out of this study. And we used them in particular to look at 90-year-olds in the following way that I'll tell you in a minute. But the first thing that we did was I said, okay, I have 14,000 people. I know if you took vitamin E or if you didn't take vitamin E 30 years ago. And I want to see if you're one of the people who took vitamin E, did you live any longer than people who didn't take vitamin E? Because vitamin E is a very popular antioxidant. It has been implicated in aging. It has been promoted as a possible way to increase longevity, reduce dementia, and do almost everything else that expensive urine does. And so we actually built the entire grant, in fact, around a lot of this, around intakes of vitamin E, vitamin A, vitamin C, as well as activities and exercise, because we wanted to study these 14,000 people and understand how it might have affected their aging, both in terms of how long they lived, but also how well they lived in terms of dementia and other outcomes. So here's the first list of things we looked at. Before I go too far, many of you know the answers and everything, but how many people in this room take vitamin C? And how many people take vitamin A? And how many are into vitamin E? So it seems like it's mostly the same hands going up that are taking all 3. So, well, this is one of those sketchy studies. And first I want to put in a serious and important couple of disclaimers here, okay? First of all, what any one study finds is not the absolute truth, and you need to know that, okay? So I'm showing you the results from our study today. I believe in it. I think we did a good job, but I think you need to realize one study does not tell us everything we need to know. The other thing is that this is an observational study. So we have not randomized people to vitamin C or vitamin E or anything like that. All we have done was said, if you took vitamin E, did you live any longer than if you didn't take vitamin E? And we do try to adjust for a lot of differences between people, but the fact is somebody who takes vitamin E is not the same as somebody who doesn't take vitamin E. And someone who takes vitamin E may be more likely to exercise or less likely to drink or do other things that really matter here. And so in an observational study, we can never account for all of these things. So take these findings with a grain of salt. However, I'll tell you right now, I believe them. Right? Doesn't that sound like a scientist? Right? So the first thing we looked at is if you took vitamin C and diet or supplements, did you live longer than if you didn't take vitamin C? And didn't work out. No effect. Vitamin A, did you live longer, diet or supplements, than if you didn't take vitamin A? No. Vitamin E, which was my personal favorite and the one that really probably got them to fund our grant in many ways, because there's really been a lot of interest in vitamin E in terms of longevity and dementia, including clinical trials, by the way. Yeah. Calcium, anyone want calcium? Soft drinks? Anyone think soft drinks is good for you? Wasn't bad for you either, though. Green tea or black tea? I had hopes there, too. So now, let me point out, this has to do with how long you live, not how well, okay? So I'm not telling you... So in the top half, I'm not telling you that doing those things won't maybe make you, it doesn't appear to make you live longer, but it might appear to make you live better, I suppose. But I think that many people like the bottom half of the list because they appear to make you live better. And now the real question is, do you live longer with them too? Right? And the answer is every single thing that's left on the list, in fact, was associated with longevity. So somebody asked me at dinner if I've changed my lifestyle because of my findings, and I guess my answer is I didn't have to. Right? Right. So individuals who drank modest alcohol, lived longer than individuals who had no alcohol intake. Individuals who had modest caffeine, and by that I mean 200 to 400 milligrams a day, which is the equivalent about 2 or 3 cups of coffee at most. Although we put everything in there. We put chocolate, we put teas, we put caffeine from colas, everything in there. But caffeine has a sweet spot. Modest caffeine was associated with living longer than people who had no caffeine. People who were normal weight or gained weight, i.e. were overweight as they aged, and that's an important thing, not when they were young, but as they aged, lived longer than individuals who were underweight, who had a 50% increase in mortality. So being thin is really terrible when you're old. Yeah. I ate all my dinner. Right? Now, activities. Exercise, as many studies have shown, mattered. 15 minutes a day on average was associated with an increase in longevity. 30 minutes was better. 45 minutes was the best. And fortunately, 3 hours was no different than 45 minutes. And in contrast to that, leisure activities that weren't primarily exercise, and there we put a variety of things, both cognitive things like doing crossword puzzles or whatever, but also any kind of social engagement, any kind of museums, any kind of reading, any kind of low physical activities that included going to churches or other kinds of meetings. Those never leveled off. So we took that up to 8 hours a day. And for every additional hour that you spent in 1981, on average, these individuals at that time were in their 70s, remember, every additional hour per day that they spent doing things was associated with an increase in longevity. So all these things are associated with living longer. That doesn't mean that some of the top ones aren't associated with reducing other outcomes of aging that we're concerned about, and we're trying to look at that now. Because, in fact, that's the whole limitation of the study is we don't want to just see who lives long, although that's interesting and important. We wanted to see how they're living and what are the things associated with successful outcomes for them. So that was the birth of the 90-plus study. And what we did is we took those 14,000 individuals that I just described from our longevity study in the 1980s, and on January 1st, 2003, when we started the study, that's our sampling frame date, almost 2,000 of those individuals were over the age of 90 and still alive, or have become over the age of 90 since then. And of those 1,900 individuals, we have successfully enrolled, actually the numbers are higher now, we're almost at 1,700 individuals. So we've gotten about 83% of everybody who is eligible to be in our study. And this, I should say, is these folks don't live in Leisure World anymore. They now live in 36 states in the United States. So we fly all over the world. My staff really liked the guy in Hawaii. It was a shame he died. Yeah. Okay, so everything I'm going to tell you from here on out is actually about these individuals. And these individuals we do see. And I mean, we see them in the biggest way possible. So we see them, for starters, every 6 months. We do a lot of questionnaires and intake and medical history and get medical records. We give them all kinds of neuropsychological tests. We do a full neuro exam every 6 months. We have an informant, or more than one, for every single person, where we get information about their functioning and other things. We ask them for their DNA. We ask them for their brain when they die. And now we are about to ask them to stick their head in an awful lot of imaging machines. So we are starting PET scans and MRIs with our latest renewal to try and understand better more about these individuals. And here's a snapshot of what they look like at baseline. So of the individuals, you can see by age 90, now there are 3 women alive for every man. So 76% of the sample, as we would have predicted, is women. The mean age of the sample is 96. Although about 40% of them live in some kind of sheltered living or with family or a group home or a nursing home, almost a third of them still live home alone with minimal, if any, support, which is pretty optimistic and nice. When we looked at their baseline exam, cognitive exam, you see that they roughly fall into about a third, which means at least the first time we saw them, about a third of them had dementia, about a third of them we called normal, and about a third of them were in that in-between zone where they had some memory or other kinds of problems but didn't quite meet the criteria yet for dementia. Now, we take these individuals, and one of the things we wanted to know, going back to this that I showed you before, is what happens here? You know, does the risk go up? Does it go down? Is it down here? Is it there? And so one of the papers that we took a look at first is, after you follow individuals in their 90s, what is their risk of developing dementia per year? And I really have to tell you that for most of my career, I was a believer in this one and a couple of others. I really thought that the risk of dementia was going to go down in individuals in their 90s or beyond. And there have been some studies that I thought were fairly well done that suggested that. And so here is what happened when we did the study. So I think that we have one of the largest studies in the world and one of the largest data sets. And I think that I'm pretty convinced now that the risk of dementia after age 65 doubles with every 5 years of age all the way through past age 100. You can see that when we looked at individuals between 90 and 94, we got an estimate that's about in the middle of everybody else's. You know, not one of the lowest, not one of the highest ones. But when we look at individuals 95 to 99, we had almost a perfect doubling from 10% to 20%. And then when we looked at what happened after age 100, we had another perfect doubling from 20% to almost 40%, which is pretty staggering. That doesn't mean you can't get past 100 without dementia, but your risk is incredibly high, unfortunately. Now, the next thing we wanted to know is, okay, all these things, most of them, some of them made you live longer, some of them didn't, but the real question is, do any of them reduce your odds of having dementia if you get to in your 90s? And I had a lot of favorites here, but I'm going to make quick work of this or I'll never finish my talk. So it appears that none of these things appear to be related to your risk of dementia after age 90, which is quite disappointing. And this includes some things that we find are related to risk of dementia in younger individuals. ApoE is not on this list, but ApoE is not a risk factor for the development of dementia after age 90. So E4, which is the genetic susceptibility gene that we talk about all the time, we actually had 3 homozygote E44s in our study who at baseline did not have dementia. And so even having 2 of those alleles, some people managed to escape. And then the individuals who developed Alzheimer's disease in their 90s or other kinds of dementia did not appear to have an excess of E4. So if these things aren't risk factors and ApoE is not a risk factor, then sort of like, well, let's find some other places to look. And so the next place we went was vascular factors. And you hear about this all the time. And you also hear about how it's been suggested that even midlife vascular risk factors, like midlife hypertension, has been reported in many, many studies to be an increased risk in later life for the development of Alzheimer's disease. So we looked at all these things. These kind of would make a lot of sense. And well, I suppose the good news is that at least one thing popped up. The only thing that distinguished dementia from no dementia in participants was high blood pressure. And what we found there was that if you have high blood pressure in your 90s, your risk of having dementia was reduced. Yeah, I didn't laugh at the time. I wasn't sure what we were doing anymore. Now, we have looked at this. This is the work of Dr. Maria Carrata, who's got grants and is spending a lot of hours trying to sort this out. But we have looked at this every which way till Sunday. And it doesn't matter. Initially, we said, okay, if you have a history of high blood pressure, did you have increased or reduced risk? And it turned out your history of high blood pressure had a reduced risk. And I said, I know what that is. What that is that somebody who tells me they have a history of high blood pressure, their blood pressure is probably lower than somebody who doesn't tell me that because they're probably on treatment and controlled. And so then we just looked at the blood pressure of individuals. So if you came into the clinic and we examined you and your blood pressure was normal, which I want to point out how few of these individuals have what we would, or cardiologists call normal blood pressure, only 13%. But you don't want to be in that 13% because your risk of having dementia was reduced by 70% if your systolic blood pressure was between 120 and 40, or your diastolic was between 80 and 90, which is what we call prehypertensive. It was reduced 80% if your blood pressure was in the full-fledged hypertensive range. So this might be, I mean, the people always look at this like this is the first time they've ever heard hypertension could possibly be anything but horrible for you. And we looked, and then I said, okay, it's not prevalent, doesn't count. What we really need to do is let's take non-demented people with and without high blood pressure, follow them in their 90s and see what happens. And that's called incident dementia. And so we did that study. That takes a few years, right? Because you only start with individuals who have no dementia at the beginning of the study. And when we did that, we found out that if you had hypertension, your chance of developing dementia over the next few years was 30% reduced compared to individuals with normal blood pressure. So in both prevalent and in incident dementia, hypertension appears to be related to a lower risk of dementia. And even though everybody thinks I've like invented the wheel when I say this, I mean, really, this has come out in a lot of different studies. I think sometimes we only remember what we kind of already believe. So here are 4 studies from around the world that have basically published the same thing. In some of them, they called it low blood pressure or hypotension, but the bottom line is that they found that individuals with the highest blood pressures actually had the lowest risks in these studies. And one of the things that these studies have in common is that they tend to be among some of the older studies in the United States and the world. So Bronx Aging Study, I actually was privileged to work in 30 years ago when I was doing my fellowship. I was in the Bronx at Albert Einstein, and this was the beginning study that the first study I ever worked in. And the study at that time, we enrolled people between ages 75 and 85, so the average age was 80. And you can see that a decade or two later, when the average age was actually approaching 90, they found a similar result. So I think that we ignore this at our own peril. I mean, replication is important in science, and finding it in one study isn't very encouraging, but when you find it in a lot of well-done studies, you maybe need to think about what's going on there, and so that's one of the things we've been doing a lot. And Dr. Kurata, actually, I'm going to show you right now nobody's ever seen this data before. Well, actually, that's not true. We did mention it at a meeting, but it's unpublished data, and I think that it's really, really important. So the weight data that I mentioned earlier, it's not good to be overweight or obese when you're young. You will carry excess mortality for the rest of your life. So individuals who, even in our sample, individuals who were overweight or obese at age 21 did not live as long as individuals who weren't obese or overweight at age 21. And that was true even if they lost the weight after age 21. So being overweight when you're young is really not a good thing, but as you get older, it becomes a better and better thing. So at age 70 and 80, actually, and many studies, the CDC did a huge study where they showed that overweight individuals in their 80s had a 3% reduction in mortality compared to normal weight individuals. So as you get older, it becomes better and better to gain weight. And I think that this is what we're going to be interpreting from this data that Dr. Kurata gave me the slide to show you. So here what we're looking at is what's your risk of dementia in relationship to when you developed high blood pressure. So individuals here, our reference group, are the individuals who never have developed high blood pressure in their life. They're that 13%. Here are some individuals, they have high blood pressure, but they couldn't tell us when, and their risk doesn't seem to be much different. There are not too many people in that group, really. But the rest of these numbers are people who have developed it either under age 70, in their 70s, in their 80s, or in their 90s. And what you see is individuals who developed high blood pressure when they were young, in their below 70 or in their 70s, really the risk of their developing dementia is not any different from individuals with no high blood pressure in this case. But individuals who developed it when they were in their 80s have about a 40% reduction in their dementia, and individuals who developed it in their 90s have a 55% reduction. So it's not just having high blood pressure, it matters when you get it. And it might be that while we think of high blood pressure as a disease, especially when we get it at younger ages, that maybe it's an adaptive thing or a sign of something else going on when you get to be older. And so I want to point out that there are a lot of interpretations here that could be superimposed on this. I mean, maybe it's just that what we call normal for other ages don't always isn't what we call normal for children, for example, and maybe it's not what we should call normal for the oldest old. So maybe normal blood pressure might be different for 90-year-olds, and we need to figure out what their optimal blood pressure is. Maybe, in fact, I mean, your blood vessels look really different when you're 90 than when you're 30, and maybe you need more pressure to get through those tortuous vessels. And so high blood pressure might be a good thing under those circumstances. Maybe it has nothing to do with high blood pressure, but rather that low blood pressure is a marker for other medical illnesses, other things that are relevant. Maybe it has nothing to do with blood pressure. And I mean, this is the problem with an observational study. Maybe it has absolutely nothing to do with blood pressure. Maybe it has to do with if, as a physician, I tell you you have high blood pressure, I give you a drug, and maybe that drug that you take for the next 30 years is what's really reducing your risk. Not the blood pressure, but actually the drug might have effects that are relevant. It could be any number of things, and this is really what we're really trying to understand better right now, because I think this is a potentially modifiable factor that can change the rate of developing dementia in our oldest old if we better understood it. So our working hypothesis right now is that maybe hypoperfusion, i.e. blood pressure that doesn't get enough blood and oxygen and sugar and all the other things that the brain needs, in the oldest old, that maybe having too low blood pressure might be a bigger problem than having high blood pressure. And in fact, we're particularly interested in looking at this during sleep. So we have, or we're trying to embark. I have to tell you, you know, everyone told me that studying 90-year-olds would be hard. They didn't have a clue. But we are trying right now to measure their oxygen saturation levels and their blood pressure and other parameters during sleep. Because, you know, we're dynamic people and our blood pressure goes all over the place every few minutes, and it changes a lot during sleep and wake and other things. So we're trying to get a better handle on this as a dynamic marker. So while we haven't found other things, some of the usual things that are related to blood pressure, to dementia, we have found some fairly novel and potentially modifiable things. One of which is hypertension and high blood pressure. Another one of which is oxygen saturation in the blood. It turns out if your oxygen saturation at rest is below 93%, that you appear to have twice the risk of developing dementia. And the other thing that I think is quite interesting is this. We found out that motor function, such as grip or power of muscles or walk speed or ability to get up and out of a chair, that those things are also associated with dementia. So I'm going to show you them very briefly. Here you have a pilot study we did with oxygen saturation. Individuals who have an O2 saturation above 93 are the reference group. And compared to them, individuals below 93 had 2.3 times more likelihood of having dementia. We're trying to figure out why individuals might have a low oxygen saturation. And in younger individuals, physicians generally think of pulmonary disease, but it's not at least fulminant pulmonary disease in these individuals. It's maybe more related to heart, but not fulminant heart disease either. And so this is an area that we're really interested in. In addition, as many of you know, oxygen levels also change a lot during sleep and at night, and so we're monitoring those at night. And then in this work done by Dr. Sophia Belain in our laboratory, she has shown that if you have poor performance on a short 4-meter walk, on repeated chair stands, your balance score, or your hand grip, the power, just gripping, a dynamic, actually, with your hand. If you're in the bottom quintile, meaning the bottom 20% of individuals in any of those things, compared to people in the top 2 quintiles, that your risk of dementia is greatly increased. 5-fold overall, but you can see that slow walkers had like almost a 12% increased odds of having dementia. Individuals with poor balance, a 3.5 times increase. Poor grip strength, more than 5 times. So we're getting the feel that unlike younger people, especially with Alzheimer's disease, that actually these motor phenotypes and these motor difficulties might be more related to the brain than we had previously thought. Maybe because of common mechanisms and common risk factors, or maybe because if we can get you to walk faster and exercise, you reduce your risk of dementia. We don't know. That's what we need to find out. So, in the remainder of this time, which is less than I thought I'd have, I'm just going to show you some of the autopsy findings because I think that that's really incredibly been interesting. We have more than 200 brains to date in the brain bank, and these individuals have provided just an incredible amount of information because they let us study them during life, and then they allow us to look at their brains afterwards. So the individuals that are in the autopsy segment, you can see on average they're about 97 years old. Their brain weight is a little heavier for the individuals who have no dementia, but 50 grams isn't a whole lot of big difference. The mini-mental is a mental status test, and individuals with dementia, without dementia, out of a possible perfect score of 30, are on average up near 27, so they're really high. The individuals that we said had dementia were on average quite low, with pretty severe disease, and mini-mentals on average around 11. So we look at the brains of the individuals with dementia, and here's what we find. About 2/3 of them have Alzheimer's pathology, and the other 40% we're not sure what, if anything, they had. And most people would have predicted that, because we generally tell people about 2/3 of dementia, most any age, past 65, is due to Alzheimer's disease. So that was fine. And then we looked at the individuals who had no dementia, and almost half of their brains also had Alzheimer's pathology of equal severity. So having AD pathology does not distinguish. The pathologist could not look at this brain and tell me which ones were demented and which ones weren't, because non-demented individuals were as likely almost to have AD pathology as individuals with dementia. Got the other thing going on here, which is that there were a lot of individuals with dementia, almost that 50% Howard Crystal reported. You can see we have a similar thing, where the pathologist said, oh, this looks kind of like normal elderly brain to me. I don't see anything of too much note. I can't tell you why they're demented. Here he didn't have to tell us why they were demented, and he found in 60% the same thing. And here's an example of one of those ladies. In the middle panel, you will see a very rare genotype, ApoE22, which is reputedly a protective effect and keeps you from getting Alzheimer's disease. And this lady, in fact, did not have dementia. She did, however, have plaques, all those spots there, and she had neurofibrillary tangles, all those spots there. And you can see that she was quite comparable to a standard Alzheimer patient that you can see on this side, and quite different from a standard control with a clean brain. And yet she did not have dementia. So a lot of people would say to me, well, the reason why is because she just didn't live long enough. I mean, never mind that she made it to 99 or whatever. Yeah. But if she had lived, to be 105 or whatever her age she needed, then this was just a preclinical state, and she really did have Alzheimer's dementia. I just couldn't tell it yet. And so that is certainly a possibility, and we have considerable evidence, in fact, that we do have changes like this in our brain for many years, decades even, probably before we develop major symptoms. But if that's the case, then you would think that the individuals with Alzheimer's pathology, who were not demented, would look different in our clinical follow-up of them before death than individuals who did. So here is a study done by Archana Balasubramanian, and she did a very nice piece of work, and she said if you had a lot of amyloid plaques, the hallmark of Alzheimer's disease, before you died, these are all individual subjects you see here, and you can see they're all over the map, but on average, what was your rate of decline? And so individuals with high levels of amyloid plaques when they died had on average a rate of decline of 1 point on the mini-mental per year out of the 30-point perfect score, right? Individuals who had no pathology or no amyloid to speak of, they had on average a rate of decline of more than 1 point per year. So having amyloid in your head did not affect the rate of decline while we were following you, even if you died without dementia. So that didn't look too promising. So we became interested in the idea of multiple pathologies, and I'm going to show you some data from that. These individuals are on pretty much the same age. They have a whole range of mini-mental scores. They have what you'd expect to, and half of them have dementia in the following studies. And we were interested now not just in the Alzheimer's pathology that you see here, but we wanted to look at something that we've noticed is much more common with aging, hippocampal sclerosis, white matter disease, which is considered a form of vascular disease, microinfarcts, which is also a vascular disease, but many people claim a microinfarct, which can only be seen under a microscope, is too small to matter to the brain, that there's too much redundancy to have this little white line there matter. These are clinically silent lesions. We do not know when people have microinfarcts. We have no way of telling if somebody's got one during life, despite all of the imaging tools and everything that we have now. So we wanted to look at all these things. And Lewy bodies, which are associated with Parkinson's and big infarcts and everything we could imagine. We took every pathology we could come up with and we looked at them. And it turns out that if you have Alzheimer's pathology, your risk of having dementia is somewhat increased, about twofold than if you don't have Alzheimer's pathology. And you can see that here. So individuals with AD pathology are twice as likely to be demented during life as people who didn't. Same thing with amyloid angiopathy, which is related to Alzheimer's disease. But look at the others. If you had microinfarcts, 3 or more microinfarcts in just 6 sections that we looked at, your likelihood of having dementia was 4 times greater than if you didn't have 3 or more. If you had hippocampal sclerosis, your likelihood of having dementia was 10 times greater than if you didn't. So, I mean, I've often said, if you give me a choice, give me Alzheimer's disease. You know, it only doubles my risk of having dementia compared to other things which actually can 10-fold or 13-fold increase the likelihood of having cognitive problems. And not only that, it turns out that the number of pathologies you have really matters. So here are individuals that the pathologist said they have no pathology at all that I think is substantial, 40% likelihood of having dementia nonetheless at this age. If you had one pathology, most often it was Alzheimer's, but it could have been any of them, your likelihood went up to 60% chance. But if you had 2 or you had 3, it becomes essentially 100%. So I think the number of pathologies really matters. And here you can see it in another way. Of the individuals who have no dementia, most of them have none, but very few of them have more than one, as shown over here in this bar. The opposite happens in individuals with dementia. Some have none that the pathologist can identify, but you can see that the majority, almost half of them, had 2 or more pathologies. Because the number of pathologies probably matters not only for whether or not you're going to get dementia, but also whether the severity of your dementia. And here you can see that, where with each additional pathology, the average mini-mental score went down from mild dementia to very severe dementia in individuals who had 3 or 4 pathologies. So here's something done by a colleague, Peter Nelson at the University of Kentucky. And I think that he was trying to sort of show a lot of what I've told you about the increase in vascular disease, the increase of hippocampal sclerosis, and the increase in the relative stability of Alzheimer's pathology once people get past age 85 and 90. But when you look at this, you get the impression that, okay, there's some people who have this and some people who have that. And at age 90 to 100, it's not like that. It's that many people have multiple ones of these, and the more hits you take, I think the worse off you are. So back to what I started the thing with, aging. What is aging? I think it's a Nobel Prize winning question. I don't think hardly anybody thinks about it anymore. And so I was trying to figure it out, and I went to the source of all wisdom, Wikipedia. And in Wikipedia I found this. Aging is the accumulation of changes in a person over time. And, you know, I think this might not be so ridiculous after all. When I was giving a lecture a week or 2 ago in New York, one of the people in the audience said, you know, they say if it doesn't kill you, it makes you stronger, but I don't think that. He says, if it doesn't kill you, it doesn't kill you, but you're not stronger afterwards. I think actually he was talking about his residency, but I think he's got a point. I mean, I think some of what aging is probably, you know, an accumulation of hits of all sorts. And that after we reach a certain threshold, then we might not be as capable of overcoming them as we'd like. But I think that if we can minimize any one of these hits, that we might make substantial progress in reducing the risk of dementia for individual people as well as for populations. So, just to finish off, Numbers of people worldwide who are in their 90s and 100 are growing every day, and I'm hoping that most of you in this room will be some of them. And I hope that the risk of dementia in you, however, will be reduced by the time we get there, because we will know how to affect modifiable and other factors that maybe will make a public health impact. But to do that, we need to study risk and protective factors and causes of dementia and everything in the oldest old, because old people aren't bad versions of young people. And this came from my local Laguna Beach newspaper. Yeah. So I thank you all, and I especially want to thank my amazing colleagues and the National Institute of Health, who has funded all of our research, and Dr. LaFurla, who's the PI of the Alzheimer's Disease Research Center here, after the founding director, Dr. Cottman. It has been a pleasure tonight. Thank you all.